Lesson 8 is about area, and this should be a review for you. We'll be covering how to figure out the area of squares and rectangles, triangles, circles, and parallelograms. Now, to understand area, I think it's a good idea to review perimeter and what that means. And like for this rectangular shape I have on the board, remember perimeter, you would just figure out the distance around that object. You just travel around it, add up the lengths of all the sides, and that gives you the perimeter. And if you remember perimeter, that can be thought of as the distance around an object or a flat shape. Area, that would just be the surface that I'm shading in blue here, the surface enclosed by that flat shape. Now, God has given us the concepts of perimeter and area to allow us to design and manipulate different things that we need to survive, basically. For example, a farmer, he's going to farm a certain area of a field. He needs to be able to calculate how much area that is, and that will help him figure out how much fertilizer to put on his field, how many seeds to plant, things like that. So some concepts in algebra are maybe a little bit difficult to understand what their application is right away. They're just to help you develop good thinking and problem-solving skills. Area, though, understanding that, you can see the direct application of that and the importance of that right away. Now, when you measured perimeter, the operation of addition was the most important operation required to figure out the perimeter of an object. In area, multiplication is the most important operation to understand and to calculate the area of an object. For a rectangular shape, usually one side is considered the length, and we'll just use a cursive L there, and then the shorter side is considered the width, and so the area of a rectangle, I'll just use capital A for area, is equal to length times width. Now you could also say width times length because the order of those operations doesn't matter, or the order of those factors doesn't matter in multiplication. Now a square, remember all the sides are the same on a square, so we'll just call one side, we'll give it the value or the variable s for a side. And so the area for a square, you still have to multiply one side by another side to figure out the area of a square. So it's side times side, or you could also call it side with a exponent 2. If you remember your exponents and what those mean, that just means that you multiply a side twice when you have an exponent of 2. If it was s with a 3 as an exponent, you'd multiply s 3 times. But for area of a square, it's the side squared. Now something else to think about here, remember in perimeter, when you're measuring perimeter and when you figure out the perimeter of an object, the numerical part of your answer is just as important as the units. It's the same in area as well. The numerical part is just as important as the units. And think about something here. We're multiplying two length measurements together. So if we had like a rectangle that had units in centimeters, our length would have units of centimeters. You look up at the top of the board here, and then the width would have units of centimeters. So we're multiplying centimeters times centimeters. Okay, so we don't want to write our answer, let's say it was 10 square centimeters. We wouldn't write it 10 centimeter times centimeter. We would write it with an exponent, centimeters squared, like that. Because we know that that means centimeters times centimeters. That's a definition of how an exponent works in math. So just like we multiply the two numerical parts of the length, we also multiply the units together as well when we're calculating area. And I guess you could write your units centimeters times centimeters, but it's just a lot easier. It looks a lot neater to write it centimeters with an exponent of 2, which means centimeters squared. Now the area of a triangle, look at something over here on this rectangle. If I split that rectangle in half and I wanted to know just one half of that rectangle, that's a triangle there, right? And so to figure out that area, it would be the length times the width divided by 2, because it would be half of the area of the whole rectangle. So triangles are basically just half of a rectangle. But there are a couple of other special properties of triangles that we need to consider, and we don't say length times width divided by 2 to figure out the area of a triangle. We usually say base times height divided by 2. We just give the sides special names. Something that's real important to understand on a triangle is that when we figure out its area, it's the length of the base, or the bottom side, times the height that's perpendicular to the base. If it's a right triangle, like the triangle that I've drawn on the left there, then the height of that right side is going to be perpendicular to the base. Now the triangle on the right, though, the height is not the same thing as the right side. It's the distance from the top of the triangle straight down to the base, or perpendicular to the base. So that's real important to understand, that the area of a triangle is the base times the height perpendicular to the base divided by 2. So always try to remember that when you're doing a triangle. That's something that a lot of times you get confused on, is you forget that, oh yeah, the area of a triangle, it's the base, I know what the base is, but then I multiply by the height perpendicular to the base. Now circles, they have a special formula for area, just like they have a special formula for their perimeter or circumference. If you recall, the circumference of a circle, that's equal to 2 times pi, that means approximately 3.14, times the radius, or pi times the diameter. Now, the area of a circle, and let's just put a little radius line on here. With the radius r, its area would be equal to pi, which is again just a symbol to represent 3.14, times the radius squared. So that means times the radius times the radius. That's what radius squared means. So when you're figuring out the area enclosed by a circle, don't forget to do that. If, say, its area or its radius was 3, don't just do pi times 3. You need to do pi times 3 times 3 again. And if you can always remember, whenever you're trying to figure out area, that you have to multiply a length times a length, just try to compare it to perimeter. Remember, perimeter has units of length, area has units of length times length, or length squared. So you've always got to multiply 2 lengths together in order to figure out the area of a shape. Now parallelograms and trapezoids, those have a special method for calculating their area. They're quadrilaterals like rectangles and squares, but what you have to do on these, like this parallelogram that I've drawn, just think about that. You could split that into 2 triangles, right? You could just split it right down the middle there and split it into 2 triangles. Now what they'll do on a parallelogram like that is they will give you the perpendicular height to the base. And so both triangles that you've made, they both have that same perpendicular height. A lot of times what they'll do on these is they'll give you the length of a side, and they'll give you the length of the base, and then they'll give you that perpendicular height to the base, and they're kind of doing that just to make sure that you know, oh, I don't need to use that 5 for the height. I need to use the perpendicular height to the base of 7. And so on the top of that parallelogram, the other triangle, it also has, you would use this length up there where I just drew the 7. That would be the base for the other one. So basically you have 2 identical triangles, both of them with a base of 7 and a height of h. So parallelograms, you split those into 2 triangles, and you do the base times the height perpendicular to the base for the 2 identical triangles. So really all you have to do is do base times perpendicular height, and that gives you the area of the whole parallelogram. A trapezoid, however, you can do the same thing in splitting it down the middle to make 2 triangles, but one of them, we'll call this B1, that'll be B1 or base 1, and this will be B2 or base 2. So you have 2 triangles with different areas when you do a trapezoid. And so each triangle will have to be calculated independent of the other one. And of course, they'll always give you the perpendicular height to those 2 bases. So parallelograms and trapezoids, you split them diagonally and make two triangles and then figure out the area of those two triangles and add them together. Let's go ahead and do some practice problems now. In practice problem A, I want you to calculate the area of this shape. And so what you need to do on problems like this is break them up into shapes or areas that you're familiar with. We just went through area of rectangles, squares, triangles, circles, and parallelograms and trapezoids. So what shapes do you see within this entire shape on the board? Well, I see a couple of rectangles, and so there's a couple of ways you could break this up. You could go right through here, or you could go down like that. Either way, I think what I'll do is choose the vertical line that I drew down. So I've erased the first dash line that I drew, and you can see there that you have two rectangles. And so what you need to do is figure out the area of each of those rectangles and then just add them together. So the first one on the left there, that has a length of 10 and a width of 4. And then we'll add the other one onto that. It has a length of 10 and a width of 5. And that M on the right there, that's meters. The units here are meters. And so now let's do our multiplication. 40 plus 50 equals 90. And so we did meters times meters each time, so that means our units are meters squared. Remember, your units for area, they always have the units of length squared. Length times length. Look at this problem. Find the area of that geometric shape. And in all these, including in the book, when they say that all of the corners are square corners, that you can assume that they just mean that all the corners have right angles to them. And so anytime there's, unless it's a triangle or something, we can assume that all the corners, even though my drawings aren't quite perfect, those corners like that, those are right angles there. So always what you do first on these shapes that look like there are multiple geometric shapes within them, think about what you can break them up into, what kinds of areas you can break them up into. And so this one, it's pretty easy to see that we could split it right down here, and we would have a triangle and a rectangle to work with. Okay, so our triangle, we know that the area of a triangle is base times the perpendicular height to the base divided by 2. We don't know what the base of that triangle is. We know the length of that one side, but that's not going to help us. That length of 10, that's not a perpendicular height to the base. So we can put an 8 right here because we know that the perpendicular height to the base is 8 based on the length of that other side of the rectangle. And then the base is just going to be 20 minus 14, so that'll be 6 feet for the base. So let's go ahead and do our area calculation for the triangle. 6 times 8 divided by 2. And now let's add the area of the rectangle, and that would be 14 times 8. Length times width. And remember, it doesn't matter. We could have said 8 times 14. It's just multiplying two factors together, and the order that you multiply them does not matter. Let's simplify our fraction. When we have 6 times 8 divided by 2, we can simplify by canceling here. 6 over 2 is 3, so we have 3 times 8. That equals 24. And then plus 14 times 8, which is 112. Add those two together, and we get 136. Our units are feet, so we are doing feet times feet every time we calculated an area, and so that's feet squared are the units. 136 feet squared. Now remember, if you're understanding how to do the area calculations, you can always pause the CD when I present a problem, see if you can figure it out yourself, fast forward to the answer. If you got it right, then just go on to the next one. So remember, you can always do that. You don't have to sit and watch and go through every single problem. You try to figure them out on your own as well. Look at this problem. Find the area of that shape. The units are in centimeters on this one. Your first step, as always, is to think of how many shapes you can break this up into, shapes that are recognizable, like triangles, rectangles, circles, and squares, things like that. So on the left there, you should be able to see there's a triangle, and so let's just draw a dashed line right down here. And we know that we have to know the base of that triangle and its height. And then in the middle we have a rectangle, and then on the right side we have half of a circle. So we have three shapes to add up here: a triangle, a rectangle in the middle, then half a circle on the right. So let's start with the triangle on the left. We know we've got to figure out its base, and so we see that length of 12 along the bottom, and that means when they have that dashed line over there on the right, they mean to stop there with your length of 12, and then of course right there would be the other end. And so from there to there is 12, and then on the top from here to here is 8, so that means the base of that triangle is 12 minus 8, or 4 centimeters. And then we need the height perpendicular to the base, and what we have to do here, this might be a little confusing because it doesn't look like they gave us a height, but look at the radius of the circle. It's 4 centimeters. So that means the diameter is 8 centimeters, which would be the same thing as the height, the perpendicular height. And so that'll be an 8 here. Okay, so we have 4 times 8 divided by 2. Now let's add the rectangle, and actually it's going to be a square, right? Because we have a height of 8 and a length of 8, and so we would just say 8 squared. That's the same thing as saying 8 times 8, right? And then we have half of a circle. Remember the formula for a circle? It's pi times the radius squared, so that would be 4 squared. Now we divide that by 2 because it's half of a circle. That's a mistake a lot of times students make, is you forget to divide by 2 there, because a lot of these geometric shapes that you'll be calculating the area for, they just have half a circle instead of a whole one. So remember to divide that by 2. Just think to yourself, okay, it's half a circle, I've got to divide by 2. Now let's go back and simplify a little bit here. 4 over 2, we could just simplify that to a 2. And so 2 times 8, that's going to be equal to 16. And then 8 squared for the middle there, that's going to be 64. And then let's just take our time on that circle there. We have pi times 4 squared, or pi times 16. I'll just write it 16 pi instead of pi times 16, divided by 2. So 16 over 2 would simplify to 8. And so then we have 16 plus 64, which would be 80. And then plus 8 pi. So that means 8 times 3.14. And so you can just do that on your calculator. 8 times 3.14 is 25.12. Okay, then we can add those together and we get 105.12. Remember, our units are centimeters, so it would be centimeters squared. Remember, the units are just as important as the numerical part. If you would have written 105.12 centimeters, then you would have only got half the problem correct. Or if you would have had 10 centimeters squared, you would have got the units right, but the numerical part wrong, so you still would have gotten half credit on that. Let's do one more problem. This one's a little bit different. I want you to find the area of the shaded region for this shape here. So if you look at that, you see you have a trapezoid, and then you have that circle on the inside, which is not shaded. So anytime you do these area of a shaded region problems, you have to subtract out a certain area in order to get just the shaded region. So what you do is you figure out the area of the bigger shape. You figure that out first, and then you go back and subtract out that smaller part that's not shaded. So here what we'll do is we'll figure out the area of the trapezoid first, then we'll go back and subtract out the area of the circle, and that will give us the area just of the shaded region. So if you remember, the first thing we do on trapezoids and parallelograms is to split them diagonally. I'll just go left to right across here. It doesn't really matter. I could go from the top left to the bottom right, or the bottom left to the top right. Either way. And I see that I have 2 triangles. And notice that I've been given the perpendicular height to both of those bases, which is 9 inches. So all the units here are inches. And so the first one that I'll do is the bottom base, or the bottom triangle. Has a base of 27, a height of 9, divided by 2, and then add to that the base of 13. Now that just seems kind of weird because that's the top of the trapezoid, but it's still the base of that top triangle. It's the side that's perpendicular to the height. That's what the base is. It's the side perpendicular to the height of the triangle. And so that has a length of 13 and then times the height again of 9 divided by 2. And then we're going to subtract out the area of that circle. So that would be pi times 3 squared. So we can't simplify those fractions without getting a decimal number, so let's just go ahead and do the multiplication there. On the first triangle, 27 times 9 divided by 2, that equals 121.5. Add to that 13 times 9 divided by 2, and that would equal 58.5 inches squared. We won't worry about writing our units right now. And then minus pi times 3 squared, or pi times 9. I'll just write 9 pi down. And then let's go ahead and add 121.5 and 58.5. That'll be equal to 180. Subtract from that 9 times pi, or 9 times 3.14, which would be 28.26. And so that's what we do when we figure out the area of a shaded region. We have our trapezoid, which has an area of 180 inches squared. Subtract that circle out in the middle, and we get 180 minus 28.26 is 151.74. And then don't forget the units, inches squared. 151.74 inches squared is the area of that shaded region. So if you don't have them memorized already, just from previous work with math, you need to memorize all those area formulas: a square, rectangle, triangle, circle, trapezoid, and parallelogram. Memorize those formulas. It'll make your area calculations easier later on in the book. Okay, well that's all for Lesson 8.